Okay, welcome geology students. This is an attempt at the third set of instructions for how to complete the final questions in the groundwater lab. Let's start with question 4. So for question 4, I want you to open a search engine, type in USGS, and click on that. You'll get the U.S. Geological Survey, and scroll down to Water Resources and hit Explore. And then under data category, we'll select groundwater and go. And then we'll go scroll down until we see field measurements. Click on that. And we'll scroll down and select site number right here. And then hit submit again. And you'll scroll down here to type in the site number that I've given you, and I'll try to type it in. I probably screwed it up somehow or another, but we'll see what happens. And then we'll select Show Sites on Map. Then we want to submit it again. And we should get an amazing transformation. There we go. And we're going to zoom into Hugo, Minnesota. And so over here on the side, you'll see that site number that you plugged in. Just click on that, and that'll open up the data set for that site that we looked at here in Hugo, just northeast side of St. Paul. There's a well there that goes down to groundwater, and here is some data for that well. And there's a list of questions there that I want you to answer. And the nice thing is that you can use this for any of the wells that there's data for, and there are quite a few wells around the country that have data. You can get an idea, you know, if you're going to buy a cabin up north or move up north or down south or out east or out west, wherever. You can get some ideas about the groundwater situation there from this data set. It can become a significant feature. I had a friend move out to near Sheridan, Wyoming, bought a fairly new house, and boy, you know, all of a sudden found out that he didn't have good water, didn't have access to good water. Brand new house, he just couldn't find it very well. So this is just a good site for you to pay attention to and answer some questions concerning. All right, so then we're going to go on to the last set of questions. They involve this map right here, or this diagram, I guess. And it's a very confusing diagram. There's a number of things here. If you look at your textbook, it talks about what's going on. It says there is a sandstone aquifer has these red lines right here. So here's a sandstone aquifer at the surface. There it's 1,000 feet. Here 900. Here 800. Here 700. So those are the red lines. And then shown in black lines, here's 1,000. Here's 950. Here's 900. Here's 850. This is called the potentiometric surface, or water pressure surface. The idea is that if you dug a well down here, say right on the 1,000-foot line, you could expect water to rise up in the pipe that you drilled down in there up to 1,000 feet. So, for instance, if you remember back to Sojan, here was that aquifer that we were talking about, and it's at the surface. But what if we drilled a well, say, up the hill here a little ways? Well, if there's enough pressure from the overlying weight of soil and rock here on the layer of rock here that contains water to push that water out, that's great. But if we go up the hill, there's less soil and rock on top of that layer of wet rock, and so we might not get water to rise all the way to the surface. But it might rise up part of the way, or it might not be affected by it at all. So that's what the potentiometric surface is. How high up in a pipe would water rise if we drilled a well at that location? Would it get to the surface? Would it not get to the surface? Or would it not rise up in the well at all? Okay, And then there are some brown lines here. These are simple contour lines, surface elevations. There's 1040 goes up and it comes back down here. Here's 1,020 feet. Here's 1,060 feet. And so this is kind of a mess. It really is. I understand that. And so maybe that's kind of the point too. And you'll notice there's a line from A to A prime here. And what we're really going to ask you to do is to cut this area in half and peel it up and look at it sideways to give us a sideways view on it, if you would. And so that's what you're going to hopefully be drawing down here on the bottom. Okay, so question 6a asks you to compare the cross-section, like I was just talking about, from A to A prime, and by transferring data down to that bottom diagram. And so you're specifically asked to draw down there where the red contours indicating the sandstone aquifer are and where the black lines indicating the potentiometric or water pressure surface are. So what you got to realize here, this is unconsolidated sediment. That's gravel, sand, just loose material at the surface, no solid rock there. Underneath that layer, there will be a layer of shale. And just like with crude oil formation, the shale really doesn't let in this case, water through it, because underneath the shale then is a sandstone aquifer. So the only way water falling on the surface can get down here to the sandstone is through where the sandstone reaches the surface and is no longer covered by the shale. And so this is an important exercise. So what you're going to do, you'll notice here's a red line. There's 700. So you'll come straight down here with a ruler and put a little dot here at the 700. And then 800 straight down here, dot at the 800. Now what we're trying to map here is where the sandstone aquifer starts. So then here would be 900. Let's see if I scroll back up there a little bit so you can get verification. 900 and then 1,000. Okay, so you'll come straight down and you'll make those dots 700. 800, 900, and 1,000. And then also notice that you have one more data point here. And that is right here, the sandstone aquifer is at the surface. And so you'll come down and you'll know where the surface is because you've got 1,040 contour line there. And so that sandstone aquifer will be right here at the surface, right about here, right around in here somewhere. Okay, and then you'll draw a line. And you'll do the same thing with the black lines, 850, 900, 950, 1,000. Okay, and draw a line completing them as well from side to side on this graph. And that's the height to which water would rise in a pipe if you drilled through to the sandstone aquifer. Remember, there's shale above it, which won't let water through it, and which is pushing down on the sandstone. And that's creating pressure that's going to push water up the pipe. Okay, so once you've done that, you'll have an idea, a cross-sectional view, if you will, and it says to label everything. I would even recommend using a red pen for the sandstone aquifer and a black pen for the water pressure surface. It might just help you keep things straight a little bit better. Okay, now in question B, it says shallow wells were drilled in the unconsolidated sediment at points X and Y. So this is the unconsolidated sediment. So if you come right down here, Y, there you could put a Y right there, right on the surface. That's where that well would be. And X would be right here on this surface. This is a two-dimensional surface, so we're not going to be thinking about in or out of the screen here on it. So X is here, Y is here. And it tells you that water fills to within 10 feet of the surface here. So here's 50 feet, so that'll give you an idea what 10 feet is. Okay, and this is the surface, land surface there. And so using that information, it wants you to sketch a profile, probable position of the water table. And a real strong hint here is to consult figure 9.1 way at the start of this lab, because there's a nice image there that shows you, you look here, this is a stream, so there's going to be a stream right here. And some of these surface features will affect where that water table is. And remember, it says within 10 feet of the surface. And so use 9.1 to complete that part of it. And then it asks you if you were to build a house at the boundary between the shale and the unconsolidated sediment. So somewhere around in here, you'll answer that question. And then lastly, part C. Deep wells were drilled into the sandstone at X, Y, and Z. So here we have X. You've already located that well here. You have one well here, Y is here, and Z is right here. You go straight down. You don't try to put it down here anywhere. We're assuming two-dimensional surface feature. Well, you're looking at this sideways. Well, yeah, Z may be back into the screen right here farther. You're going to just represent it with a dot right here. So X, Z, and Y. Okay, a little bit of alphabet problem there. And so they're drilling deep wells all the way down into the sandstone, okay, through the unconsolidated sediment, through the shale, into the sandstone. They're going to seal those wells so there's no way water can get in or out of those wells except that goes through the pipe. And that's noted on here. There are some questions that ask it. How deep would the wells be at each spot to intersect the top of the sandstone aquifer? Now, you can give me a number of feet from Y down to the sandstone aquifer, or you can just give me an elevation based on the side. So there's two ways you can do that. Okay, and then in part 1 of part C, it says, assume the shale bedrock below the unconsolidated sediment above the sandstone aquifer is impermeable. That's what I was talking about. Assume you can't get water leaking past the pipe around it. There's no way for water to get up to the surface except it goes through the pipe. And so how high would water in the pipe rise? So you've got that potentiometric or water pressure surface line on here, that black line that tells you that. And again, you can give me a number in feet that you calculate, or you can just use an elevation from the side numbers here. However you want to do that is fine. For each of the 3 wells. So I want to know that for each of the 3 wells. And then lastly, related, it says, are these deeper wells, the ones that are down in the sandstone down here, are they flowing artesian wells? In other words, the water gets to the surface. Are they non-flowing artesian wells? By that, we mean that water actually gets above the sandstone, but it doesn't get all the way to the surface. Or are they non-artesian wells? In other words, water doesn't rise above the sandstone at all. And that's pretty much the end of that question set. Hopefully this helps, and I will talk to you later. Thank you. Bye.